In this video, we are going to go over multiplying a polynomial with another polynomial. If both the polynomials are binomials, which means each have two terms, you can use a method called the FOIL method. FOIL stands for first, outside, inside, last. What that means, you take your first term and multiply those together. Then you take the terms on the outside and multiply those together. Then you multiply together your inside terms, and then you multiply your last terms together. What this is doing, this is taking each monomial within the binomial and multiplying it to each of the monomials and the other polynomial as well. So when we do this out, we're going to get first x times x. Next, we're going to do outside. So that's x times 6. Then we're going to do the inside terms, which is 4 times x. And then we're going to do the outside terms, which is just 4 times 6. Let's simplify this down. X times x is x to the 1 times x to the 1, which we know would be x to the 1 plus 1, which is x squared. X times 6 is just the same as 6x. Then we have 4x, and 4 times 6 is 24. Now just combine the like terms. X squared plus 6x plus 4x would be 10x plus 24. That would be our answer when we multiplying these two binomials together. Let's look at one more example of multiplying binomials. 2y plus x times 3y minus 4. Starting with the first terms, 2y times 3y. Then we're going to do the outside terms, 2y minus 4y. So that'll be minus 2y times 4. Then our inside terms, x times 3y, so that's plus x times 3y. And then our last terms, x times 4, so minus 4 times x. Simplifying this, we're going to get 2y times 3y, which 2 times 3 times y, minus 2 times 4 times y. All we're doing is rearranging the terms. Add that to 3 times xy minus 4x. Simplifying this, 2 times 3 is 6, y times y is y squared, minus 2 times 4 is 8 times y, 3xy minus 4x. There's no like terms, so this would be our final answer. In this case, we have a binomial multiplied to a polynomial known as a trinomial, so we can't do FOIL. But like in FOIL, we want to distribute each of the monomials in the first polynomial by each of the monomials in the second polynomial. So let's start by taking care of our x. This x will get distributed to the x squared, the 3x, and the 2. So we're going to have x times x squared plus x times 3x plus x times 2. Now, let's take care of the y. We're going to have y times x squared plus y times 3x plus y times 2. Let's go ahead and simplify this. X times x squared is x to the 1 plus 2. This would be 3 times x to the 1 plus 1, because we have x to the 1 times x to the 1. Writing the numeric value first, this would be 2x. Our next term would be yx squared. Our second to last term, writing the numeric value first, would be 3xy. And our last term, writing the numeric value first, would be 2y. This comes to be x cubed plus 3x squared plus 2x plus yx squared plus 3xy plus 2y. And this will be our final answer because there are no like terms. There are terms that come very close to that. For example, we have an x squared here and an x squared here, but because this y is multiplied to that x, we cannot combine those terms. We're going to distribute this monomial x to this x, the x squared, and the negative 3z to the 5th. So x times x plus x times x squared, and then this will be a minus x times 3z to the 5th. Now let's take care of the 4. Adding a 4x, then adding a 4x squared, and then subtracting a 4 times 3z to the 5th. Let's simplify this. X times x is x squared. X times x squared would be x to the 3rd, because you'll have a 1 plus 2, minus, putting the numeric value first, we're going to have 3xz to the 5th, plus 4x plus 4x squared minus 4 times 3 is 12, z to the 5th. Now, we do have a like term. We have this x squared and this x squared, so we can combine those terms. So that's going to be x squared plus 4x squared will be 5x squared plus x to the 3rd minus 3xz to the 5th plus 4x minus 12z to the 5th. And that would be our answer when multiplying these two polynomials together.